Okay, if you haven't done the warm-up, do it. Pause the video, do it. Otherwise, you're gonna be like just spoiled. Do you like my lovely table here with all those marks? Alright, so this one here, point estimate, that's just your p-hat here. This is about the proportion. Follow your 4 steps. If you notice, I got self-centered here and I said I want to. If you're still saying we, it's fine. One sample is the interval proportions. I start to abbreviate. Yes, it's a random sample. Normal, again, you gotta check that n times p-hat. You gotta show that you did it. Don't just write that. That's not going to work. Independent. So yes, there's at least that many adults. Alright, there's my formula. Oh, post-it note surprise. You should be excited. Alright, move that little cursor arrow. Okay, so there's my formula. There's my interval. We are 99% confident that the interval 0.253 to 0.327 captures the true proportion of adults who use the internet for shopping at least a few times a year. Okay, my surprise here. There is a way to do this on the calculator. So the first thing that you would do, you will go to Stat. You will go over to Tests. You will go down to A. 1 prop Z interval. Alright, the X. So in this problem we had 29%. So if I do 0.29 of 1025, I get that number. 1025 is my N. My C level is 0.99. The horror! What has happened here? I'll tell you what's wrong here. Fear not, folks. What do you think's wrong? So I'm supposed to be figuring out what percent use the internet for shopping. I'm supposed to be figuring this out about a people. 297.25 people. That doesn't make any sense. We don't have a quarter of a person. So, the problem is this X is supposed to be a whole number. X and N are whole numbers. We're counting things here. So I can't have a decimal here. So instead of using this 0.25, we're just going to round to the nearest whole number. Okay? When you round to the nearest whole number, if I take that 297 divided by the 1025, most likely, actually I'll do it here, show you here on my lovely phone. So if I do 297 divided by 1025, I get 0.2897. If I round that to 2 decimal places, it's 29%. Alright, so that's what's going on here. Alright, I hit calculate. Ready? Voila. Okay, if you're going to do it this way, this is what you're going to give to me. You're going to give me what you typed in and what you got out. So this red box replaces this stuff right here. Everything else is still the same. Okay? So don't get like, woohoo, I don't have all that work to do. Well, you still do. And be careful. Multiple choice questions oftentimes throw those formulas in there. Alright? So you want to make sure you remember those formulas. I'll cover this back up so I'm ready for next time. Okay. Alright, she said that at most 30% of adults use the internet for shopping. Is she correct? No, it's at least, at most 32.7%. If she wants to estimate the percentage to determine the maximum impact, she would use that upper number. She's better off overestimating than underestimating, people. Alright, this is so sad. I have an activity for today. It did involve some food, and we're not doing it. I don't know, maybe sometime we'll get back together and we can do the activity. Anyways, so let's look here. Estimating a population proportion. How do you find the minimum sample size? Alright, so remember our margin of error. It looks like this. So it's Z star, and then it's P hat times 1 minus P hat over N. So that's the margin of error, right? What we're going to do here with this minimum sample size is that we want this answer to be less than or equal to whatever margin of error they give me in the problem. So what's happening here, let me backtrack a little bit. is that we are trying to find the minimum sample size. So let's say a statistician's like, oh, I want to figure, what's the 95% confidence interval for the president's approval rating? And I want to be 95% confident, and I want a 3% margin of error. How many people should I talk to? So they can use this formula here and try to find the minimum sample size. So basically what you do here, you solve for n, but then you always round up your answer, okay? What are you going to use for p hat? So you're going to get this information. You're going to get this information in the problem. This is your variable, so you need something for p hat. So either you're going to have a problem that'll tell you prior information, or p hat's going to be equal to 0.5. I'll tell you why we're going to use 0.5 in a second. All right, so it says, suppose you wanted to estimate the true proportion of students at your school that have a tattoo with 95% confidence, and the margin of error no more than 0.1. So 95% is my z-star 1.96. I want my margin of error to be 0.10 right there. P hat, I have no prior information, so I'm putting 0.5 here, 1 minus 0.5 all over n. Okay, be careful when you solve this. So what I would do first is I'd divide both sides by that 1.96. So I'm going to have my 0.1 divided by 1.96. So this is 0.0510. Then I would square both sides. So when I square both sides, it looks like this. And then it's kind of like you want to cross multiply. Then I can get n over here, and I can just take this right here, this 0.5, times 1 minus 0.5, divided by this answer up here, and I get 96.04. I know it is 0.04, but I told you, round up. We need to talk to 97 kids, okay? Okay, next problem. Looks pretty much the same, but now a prior study revealed that 9% of students had tattoos. So instead of using the 0.5 there, I'm going to use the 0.09, 1 minus 0.09 divided by n. Alright, so this looks pretty much the same again. So I get that. Oh, sorry, that's not that anymore. I'm going to square it. So again, very much the same as what it was before. Okay, cross multiply, and then we're going to end up dividing. So I got my 0.09 times 1 minus 0.09 divided by that answer right there. 31.46. Again, I'm going to round that up. I'm going to say I need 32 students here. Wow. What you notice there is that I need a lot fewer students if I have that prior information. So think about what's happening here. So the only thing I really changed is that p hat part, right? So remember, this is that p hat 1 minus p hat over n. When we say let p hat equal 0.5, basically what's happening in this part of the formula is I have 0.5 times 0.5, so I get 0.25, right? Is there any other p hat I can pick to make this number bigger? If I say 0.4, then I'd have 0.4, 1 minus 0.4 would give me 0.6, 0.24. If I did 0.3, I'd have 0.3, 1 minus 0.3, I'd have 0.7, 0.21. So there's no p hat I can pick that is going to make this bigger. Oh, well, what if you pick 0.51, Mrs. Painter? Okay, 0.51 is this is going to be 0.49, and I can't do that math in my head, so I got to grab my calculator. But see, look, still, nothing is bigger than that. So that is my conservative method. If I have no prior information, that is giving me the highest minimum sample size I would need. Okay? So that's why it works. All right, on the next page, you should be able to solve the first 3 problems, and then I might have to walk you through the 4th one. So, or the last one, yeah. The first 3 look like this. So again, pause the video, try it on your own. If you're not getting the same answer for me here, it's because you're rounding here. Keep 3 decimal places, and then you'll end up with the same answers as me. I'm probably also using the answer button when I do these on my calculator. That might be another reason. But just keep those 3 decimal places for your critical values. All right, down here for that last one, what we're doing here is we're going backwards and we're trying to find what that critical value is. So I get that answer right there. Again, when I'm creating a confidence interval, it's the area bound by those 2 numbers. So when I find that there, I find that area in there, I come up with it's probably 90%. It's like 89 point something. So most likely it's probably 90%. You could look up both of those numbers in the chart and you're just trying to find the area in between. Okay? All right, folks, that is it for this lesson.